When you divide polynomials, you have certain theorems that you can apply, such as the remainder theorem and the factor theorem. The remainder theorem basically says that when you divide a function by a polynomial, then the remainder is equal to f of c, which means basically that you can take the c and plug it in for f of c, and that's going to give you the remainder. Now, the factor theorem says basically if you do the remainder theorem and you get f of c equals 0, then this polynomial has to be a factor, or go into it with a remainder of 0. These are just reminders of what happens when you divide polynomials and have remainders. It says the remainder is equal to f of c. If the remainder is equal to 0, first of all, it's a factor, and it's an x-intercept, and it's a solution. Let's look at an example of doing this type of work. So the first thing that I would do coming to this example is to figure out, is this going to be a remainder of 0? Now, you could do that one of two ways. You could put in -4 into this function and figure out if you get 0, or the other way is to use synthetic division. So let's take a look at doing both of those. And first of all, if you remember, it's going to be a reminder on synthetic division. You're going to have a 1. Now the x squared is gone, so you have a 0, -28, -48, and this out here is going to be a -4. And the 1 comes down, you multiply and add. Multiply and add. Multiply and add. Not surprising that you get 0. Also, what you could do is you could say, all right, this is f of x. You can say f of -4 by plugging that into here. You're going to see that that is going to be 0 as well. So whatever way is easier for you, you want to find out if it's a factor or not. Now, the benefit of using synthetic division is that you have your factored polynomial. So what this really means is that x plus 4 times, and then it's going to be x squared minus 4x minus 12 is equal to this f of x. Now, the last part of this is to determine if this can be factored as well. So we're going to see if you can factor that. I would set up your parentheses, put in what must be true. You know you have a plus or minus because this is a minus sign. And now you're looking at the factors of 12 that differ by 4. And so that's going to be 6 and 2. So that looks like this. Therefore, your f of x is going to equal the following, and that is in factored form. Now, if this doesn't factor, then you would be done at this step of the game. This can tell you a few things about the graph. Now, if the question is what are the zeros or the solutions, same idea. What you can do is set this equal to 0, which means that x is going to be equal to a -4, -2, and 6. That's going to be where that crosses the x-axis or the x-intercepts as well. So that's some information on dividing polynomials and being able to apply the remainder theorem and the factor theorem, and being able to factor out a polynomial where normally it would be quite challenging to factor